Okay, good day everyone. This will be a short discussion, introduction to statistics and probability. So statistics and probability will be branches of mathematics. So sorry for the getting stuck. So this will be a branch of mathematics that studies the laws of random events, including the collection, processing, analysis, and presentation of data for such random events or variables. So when we look at statistics and probability, we are looking really at the behavior of random variables, which means that the behavior of these variables will be governed by their natural occurrence and will not be subject to a um, fixed fixed cycle, fixed trends. Even when we're looking at trends, we do not have the exact copy of the expected trends as forecasted. So it will still be the behavior of a random variable. Okay, so there are three main aspects of statistics. We are looking at the development of designing the process of data collection, the description phase, which will be the descriptive uh, statistics, whereby one's agenda is to actually characterize the data in summary form. This is where we provide the collected data in the more easily understood form. So raw data are processed into several forms of data presentation so that the collective character of the data of the population as represented by the sample data can now be inferred from the behavior of this data in summary form. And then inference, this is where we provide generalizations about the population from the results of the sample data. Okay. Now, what would be the coverage of descriptive statistics? While we say that there are three main aspects of statistics, which the first component of which is design, this is to emphasize that descriptive and inferential statistics cannot be pursued relative to providing characterization of the population behavior or making conclusions about the population behavior if the data collection methodology has not been rationally validated and designed by whoever will collect the data. Okay, so for descriptive statistics, we are looking how one wants to characterize or organize the data set. So data sets in descriptive statistics are presented in tabular form, graphs, summarized statistics, or visual maps, and other forms of generalized data presentation. Why do we say other forms? We should provide in here that other possibility. So other forms or formats of summary data presentation. Why? Because a a researcher can devise his or her own mode of presentation. Like if you're working with big data, you may provide networks, you may provide clustering, you may provide if you would like to map transmission of diseases or transmission of information, or let's say the progression of a meteorological event, or let's say the growth of algae, whatever the field, you may devise your own mode of summary data presentation. And that will be still within the domain of descriptive statistics. And then we have inferential statistics. What will this be? Inferential statistics will be the area where one makes decisions, makes conclusions, forecasts, or make predictions about the behavior of a population. But this behavior will be culled or will be extracted from the sample data, and the sample data cannot be overemphasized to be and must be representative of the target population. Okay, so one uses inferential statistics or inductive statistics. Why do we call that? Because from the particular knowledge of the behavior of the sample data, we generalize a conclusion. So that's why we can call inferential statistics as inductive statistics. Okay, now what then is probability? Probability is a measure that a certain event or outcome will happen. Why do we consider in statistics any phenomenon to be referred to generally as an experiment? Because when you experiment, the results of that experiment will always be uncertain. You do not experiment when you know the results of what you're doing. Experimentation means you're trying to explore all possibilities, all potential outcomes of that experiment. So for probability, measurement, we always look at any component of that phenomenon to be an event. And probability is defined as the relative frequency of a specific event occurring. So what would that be? It will be the frequency of a specific event divided by, so we will have to be very careful that the divisor for the frequency of that specific event or the event of interest must be divided by the total, okay, by the total the um, of all the possible events, okay. And this tells us that a probability measure will always be between 0 and 1 inclusive. It cannot be less than 0, nor can it be greater than 1. Okay? And what do we also need to understand in here? We need to understand that when we generate statistical information, we will have to be very careful about how we identify the sample. We said the sample will be smaller than the population, much smaller, but it has to be representative. So the process of determining a representative sample of the population will only be possible if we observe protocols or if we are able to adopt valid procedures. So sampling will be the process of identifying the representative units of a population. So some of the sampling modes that one can use could be cluster, proportional, stratified, simple random, and variable sampling. In the introductory part of our lesson, we already introduced these sampling methodologies, and we need to be very aware that one may adapt a combination of these sampling methodologies. The core idea of sampling is to arrive a at a mean lean sample size that will minimize error but would optimize representation of the population. Okay, what are the steps in inferential statistics? First, we sample. Okay, so we decide how the sample will be selected. Okay, and this tells us that we need to first also identify the sample size. Then we collect the sample data. Okay, so from how to the collection of data. Okay, and then after the data is collected, or you can partially encode the data as the sampling proceeds, or the collection of the data proceeds. We summarize the data. Okay, then we present the data in appropriate summary formats, and in the analysis phase, it will always be good practice to provide transparency information. Ibig sabihin, you provide any information that users of your research results will need to know about any form of um, limitations or constraints which through the process of data collection or through the process of experimentation, some forms of constraints were met. And that is for the purpose of providing the most accountable and ethically sound declaration of how the data has been collected and forms of what forms of adjustments on the meaning, the comprehensiveness, or the applicability of the results will have to be made should there have been some forms of constraints met during the process of data collection. Okay, and then one now reports the results, usually using technical language. And then what do we need to be aware of? We need to be aware that there is such a thing as forensic statistics. Ano ba tong forensic statistics? Okay, so forensic statistics is a statistical form of analysis whereby the results of such analysis are accepted as evidence in a court of law because it can be established as to the high probability that such results can be verified to be valid. Okay? When we say verified as valid, that would mean there will be a very insignificant level of error. So what do we need to recall? When we provide DNA evidence, let's say in court, of how one can establish that this criminal actually committed the crime because he has left behind his DNA in the crime scene, then that tells us that forensically and statistically, it has been established that from among millions of people, there is a very small chance that the DNA results, okay, as lifted from the crime scene is associated with this criminal. That would be a very, very small chance. Okay? Sinasabi pa nga yung DNA. Let's say if you are twins, if you're triplets, quadruplets, you will be sharing similar DNA. But the similarity can be very high, but when one establishes that it will be this twin who has committed the crime, then statistically, you still can refine the DNA results so that one can pinpoint who between the twins or who among triplets or tuplets is the criminal, so that no innocent person will be incarcerated or brought to prison for some crime that he has not committed. So this is the explanation of how forensic statistics is an acceptable method of establishing guilt in any criminal prosecution. Okay, so this is where we end our discussion on statistics and probability, to introduce now to you on the need for processing data and providing for the evidence in making decisions. Okay, if you have questions, let me know later, and thank you for your attention. Good day.